For decades, we've had a pretty solid idea of how the universe began, the Big Bang, 13.8 billion years ago. The story goes that from a single, impossibly dense point, everything we see today slowly, methodically took shape. It was a story of gradual construction, cosmic dust patiently clumping together, and small structures merging over eons to form the great galactic empires we see in the sky. This is the standard model of cosmology, the rulebook for our universe. But what if the first few pages of that rulebook are a little incomplete? The James Webb Space Telescope, our golden eye in the cosmos, has been staring back to the dawn of time. It was designed to see the universe's first light, the birth of the very first galaxies, and it has succeeded beyond our wildest dreams. But it's also sent back images that have shaken up our understanding. We're seeing things that, according to our own models, are a little bit too big, a little too bright, and a little too mature for their age. When astronomers pointed the Webb telescope at the deepest, darkest patches of the sky, they were hunting for the galactic equivalent of toddlers. They expected faint, small, and somewhat messy collections of the first stars, the humble seeds from which everything else would grow. Instead, they found giants. In the cosmic darkness, just a few 100 million years after the Big Bang, Webb saw galaxies that were shockingly massive and brilliantly bright. A stunning example is a galaxy named Jade's GSZ 14O. We're seeing it as it was only 290 million years after the universe began, a mere 2% of its current age. But this galaxy isn't some primitive cloud. It's estimated to be hundreds of millions of times the mass of our Sun and blazing with light. More shocking still, analysis has revealed the presence of oxygen. In cosmology, elements like oxygen are considered metals, and they aren't created in the Big Bang. They're forged in the fiery hearts of stars and scattered across space when those stars die. To find a significant amount of oxygen so early means at least one full generation of massive stars had to have already lived, died, and seeded this galaxy with heavy elements. All of this had to happen in what seems like an impossibly short amount of time. These findings sent a shockwave through the astronomical community. The most provocative and controversial claims that bubbled up from early interpretations suggested some of these galaxies could have stars that were older than the universe itself at that point in time. Imagine finding a picture of your grandparents dated before they were born. It's a paradox, an impossibility that forced a fierce scientific debate and a much closer look at the data. So why is this such a big deal? Why can't galaxies just form quickly? It all comes down to the standard model of cosmology, also known as the lambda cold bark matter model, or LCDM model. This model has been incredibly successful, but a core principle is hierarchical formation. Think of it like this. After the Big Bang, the universe was an almost perfectly uniform soup of gas and dark matter. Gravity, acting over immense timescales, slowly pulled matter into the slightly denser regions. Small clumps formed first. Those small clumps then gradually merged to form bigger clumps. It's a bottom-up process. You start small and get bigger, and it takes a lot of time. According to our best simulations, there just shouldn't have been enough time for gravity to build such massive galaxies so early on. Finding these behemoths in the infant universe is like finding a fully built skyscraper on a construction site the day after breaking ground. It seems to defy the known laws of cosmic construction. This is the impossible early galaxy puzzle. It has forced us to ask a thrilling question. Is our understanding of how the universe got started wrong? When faced with an observation that seems to break physics, scientists have two choices: throw out the rulebook or check if they're reading the scene correctly. Before declaring the Big Bang Theory broken, every alternative has to be investigated. And a big clue came from something hiding in plain sight. As researchers looked closer at the Webb images, they realized some of these impossibly bright galaxies were actually hiding something else at their cores: an active, supermassive black hole. We think of black holes as cosmic vacuums, but the material falling into a black hole forms a swirling superheated disk that can outshine entire galaxies. This intense radiation can make a galaxy look far brighter and therefore far more massive than it actually is. Once astronomers started to account for this extra light, the picture changed. Some of the most impossible galaxies turned out to be imposters, not nearly as massive as they first appeared. The puzzle was partially solved. The cosmos wasn't quite as broken as it seemed. It was a perfect example of science in action: a puzzling mystery, a deeper investigation, and a new, more nuanced understanding. But it didn't solve the whole problem.
We are now deep in the heart of a cosmic mystery, peeling back the layers of our universe's origin story. If you find this journey to the edge of what we know as fascinating as I do, this is a great time to subscribe and join us for more explorations into the biggest questions in science. Hitting that button ensures you won't miss the next chapter. Even after weeding out the imposters powered by black holes, a serious puzzle remained. There still seemed to be more massive galaxies in the early universe than our standard model predicts. They might not break the model, but they're definitely stretching it to its limits. So what could explain them? The leading hypothesis isn't that our timeline of the universe is wrong, but our assumptions about the efficiency of the early universe were. Perhaps in the early cosmos, galaxies were simply much better at their job. Evidence suggests that early galaxies converted their available gas into stars at a pace that is almost unimaginable today. They were hyper-efficient star factories running in cosmic overdrive. In the modern universe, star formation is a relatively slow, self-regulating process. As gas clouds collapse into stars, the heat and radiation from those newborns push back, slowing things down. But in the primordial universe, conditions may have been different. The chemical composition of gas was simpler, and the dynamics of dark matter might have allowed for runaway starbursts on a galaxy scale. This doesn't overturn the Big Bang, but it does force us to rewrite the first chapter of galaxy formation. The early universe wasn't a place of slow, gradual assembly. It was a place of violent, rapid, and incredibly productive creation. The first galaxies didn't just crawl into existence, they burst onto the scene in a blaze of glory. This feeling of cosmic vertigo, of a discovery that seems to upend everything we know, isn't new. Astronomy has a long history of age problems. In the past, certain stars or clusters appeared older than the accepted age of the universe. Each time, these crises were resolved, not by junking the entire model, but by refining it with better data and a deeper understanding of astrophysics. What we're seeing with Webb seems to be another one of these revolutionary moments. The term crisis in cosmology gets thrown around a lot, but most scientists see it not as a sign of failure, but as a tension that points toward new physics. Interestingly, while Webb has been creating this new puzzle, it has also been used to add precision to another long-standing crisis known as the Hubble tension, a disagreement over the universe's precise expansion rate. So far, the data from Webb has confirmed the tension exists, but hasn't resolved it, showing just how complex these cosmic questions are. This tells us something profound. The standard model isn't a fragile house of cards. It's a resilient framework that has withstood decades of testing. The discoveries from Webb aren't signs that the model is broken, but that it's incomplete. We're being forced to add new details and account for processes we never knew existed.
So has the James Webb Space Telescope found galaxies older than time? The provocative answer is no, but the real answer is far more exciting. It has found that the universe's childhood was more dramatic and precocious than we ever imagined. It has revealed that our story of a slow, steady beginning was far too simple. The real story is one of shocking speed and startling efficiency. It's a story where the first cosmic cities were built in a fraction of the time we thought possible. The universe didn't just learn to walk, it was born running.